everybody. This tutorial is about your metric or SI, System International Units, and converting. Specifically, we will be looking at converting from a metric prefix back to a base or fundamental unit. For example, if you have 158 millimeters, what would that be in meters, the base unit of meter? In fact, the first thing we need to do is understand what the base SI units are. Now, there are 6 or 7 base SI units, and they are listed in the table in the back of the book. But the only ones we're going to be looking at today are the ones for mass, which is the gram, the one for volume, which is the liter, the one for time, which is the second, and the one for distance, which is the meter. And those are the 4 basic metric units that we'll be working with, or SI units. Metric is actually a sort of an obsolete word now. We use SI, System International. All right, so in order to understand how we're going to be able to convert, it is a good idea to understand where the information we're going to be using comes from. And that means going back to the basics, the extreme basics. So I want everybody in the middle, this way and this way. I want you to put a dot right there for a decimal point. Okay? Now, to the right of that, I want you to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, that one went very big. 11, 12 blanks. 12 blanks, okay? And to the left, I want you to do 10 blanks. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, we're going to use this to help us to see what we're doing and why it works. All right? So that everybody starts on the same page. Now, first off, if you have 1, 2, 3, 4, 5, 6, 7, 8, or 9 of anything, whether it's grams, liters, seconds, meters, if you have 1, 2, 3, 4, 5, 6, 7, 8, and 9, then you're right here at the base. Okay, so that would be the gram, the liter, the second, or the meter. And you can have 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now, in scientific notation, the power of 10 that would be associated with this would be 10 to the 0 power. For example, if you had 5 grams, that would be 5 times 10 to the 0 power, because 10 to the 0 is 1, and 5 times 1 is 5. Okay? Now, all of these decimal places, whether they're greater or less than, above or below the decimal, they all have their own prefix names and letters. However, we seldom use but just a few, and those are the ones that we're going to be looking at. So we're going to start by jumping up. We're going to skip 2 spots. I think most of you know, for example, this is actually deca, but we very seldom use that. We're more likely to use this place right here. If you have 1, 2, 3, 4, 5, 6, 7, 8, or 9 thousands in SI, 1,000 is a kilo. And so you could have a kilogram, a kilo liter, a kilosecond, or a kilometer. We use a lowercase k to represent kilo, okay? And I think I'm going to highlight these by underlining the kilo in the base. There we go. Now, for scientific notation, this is 1 followed by 3 zeros. If we wanted to put this 1,000 in scientific notation, we'd have to move the decimal 3 places, which means to the left, we add to the power of 10 right here, so we get 10 cubed. So you could have 1, 2, 3, 4, 5, 6, 7, 8, or 9 times 10 cubed, or 9,000. Okay? All right. Now, we're going to jump another 2 spots. Again, these do have their own prefixes and names, but I don't think I've ever seen them used. We're going to look at this spot right here. Okay? Now notice from 1 to the decimal, you've got 1, 2, 3, 4, 5, 6. In English, we would say that's 1, 2, 3, 4, 5, 6, 7, 8, or 9 millions. All right? So this is the millions place. So we have the ones, the thousands, the millions. But in SI, this is called mega. We use a capital M for mega. So you could have a megagram, a megaliter, a megasecond, a megameter. Okay, it's mega. And because in scientific notation, this would be 1 times 10 to the positive 6, then the power of 10 associated with mega is 10 to the 6. We're going to see how to use that in a little bit. All right, one more place. We're going to skip 2. Again, we don't really care what they are. We don't ever see them. And we're going to put a 1 right here. If you have 1, 2, 3, 4, 5, 6, 7, 8, or 9, followed by 9 zeros, you have a billion. In English, we would say a billion. But in SI, 1 billion is a giga. Okay, 1 billion is a giga. So you could have a gigagram, a gigaliter, a gigasecond, a gigameter, and if you've ever watched Back to the Future, you could have gigawatts. Okay, the amount of power needed to make that time machine work. Okay, now since it's a 1 followed by 9 zeros, if we put it in scientific notation, you'd have 1, 2, 3, 4, 5, 6, 7, 8, or 9 times 10 to the 9th power. Okay? All right. Now, so those are all the big ones. Now let's look at the other side, the fractions. Now, most everybody knows that if you have a tenth of a whole, that is a deci. But in physics, we very seldom use that. I think you do use it in chemistry maybe, I'm not sure, but we don't use it in here, so we're just going to put a 0 there. We actually do use the next one, the hundredths place. In English, we would call that 1/100th of the whole, okay? In SI, it's called a centi. So you could have a centigram, a centiliter, a centisecond, a centimeter. Okay, the centi. And because it's 1/100th, 1 2 places to the right, you subtract when you move to the right, so you get 1 times 10 to the negative 2. So 10 to the negative 2 is the power associated with centi. Now, interestingly enough, we're also going to look at the very next spot. It's also very commonly used. In English, we would say that this is 1/1,000,000th. No, not millionth. Ugh, sorry guys. 1/1000th. Okay? Tenth, hundredths, thousandths. So if you have a whole and you split it up into 1,000 pieces, each piece is 1/1000th. Now, in SI, 1/1000th is called milli. And we're going to use a lower letter M for the prefix letter. So you could have a milligram, a milliliter, a millisecond, or a millimeter. Okay? And 1/1000th would be 10 to the negative 3 in scientific notation form. Okay? Now we get to jump a few spaces. Let's see, we're going to jump 2 spaces. Don't care what those are. And we're going to look right here. All right, so 1, 2, 3, 4, 5, 6. If we move the decimal until it was behind that one right there, we've moved it 6 places to the right, so that would be 10 to the negative 6. 1/1,000,000th in English. Here's 1,000,000 over here. Here's 1/1,000,000th right here. But what is the SI prefix for 1/1,000,000th? All right, it's actually called micro. Now, here's the problem. I would like everybody to look. We've already used a capital M for mega, a lowercase m for milli, so what in the world do we use for micro? Well, in science, when you run out of English letters, you go to Greek letters. So what is the Greek letter M in the Greek alphabet? The Greek letter M is the Greek letter mu. It looks like a U with a long tail on the front. And it represents micro, okay? So you can have a microgram, you can have a microliter, a microsecond, or a micrometer. 1 millionth, 10 to the negative 6. Now that's kind of interesting. Okay, we're going to skip 2 more places. Boom, boom, and put a 1 right there. You could have 1, 2, 3, 4, 5, 6, 7, 8, or 9 billionths. And in SI, a billionth is a nano. Okay? A billionth is a nano, and we use a lowercase n, so you can have a nanogram, a nanoliter, a nanosecond, a nanometer. And that would be, instead of 10 to the 6, it would be 10 to the negative 9. Because if you had one of them, you'd have to move the decimal 9 places to put it there, so that's 10 to the negative 9. All right, last one. I'm going to skip 2 places and put 1 right there. So if you had 1, 2, 3, 4, 5, 6, 7, 8, or 9 of these, that would be 9 trillionths in English, but in SI, a trillionth is a pico. We use a lowercase letter p, so you could have a picogram, a picoliter, a picosecond, a picometer. And we've moved 12 places, so it's 10 to the negative 12 in scientific notation. All right, now, so the base metric units, the gram, the liter, the second, the meter, there are a couple of others like the coulomb of charge and a couple of others, but they're specialized. All other units in physics, other than the base units, they're made up of combinations of these, okay? For example, a Newton of force is a kilogram times a meter divided by second squared, okay? So that's not a base unit. You can still use the metrics with it, but it's not a base unit itself. In fact, if it's not a base unit, it's called a derived unit because it is derived from or comes from a combination of other base units. Just so you know. Now, how are we going to use this to help us convert a value from the base, from the metric unit, the metric prefix, back to just the base? If we want to go from kilometers to just meters, how do we do it without having to always remember which way do you move the decimal, how many places? That becomes a pain in the butt. All you have to do is remember what the power of 10 for each of these is, and it becomes very easy. All right, just watch. Here we have 12.6 kilometers, and we want to go back to the base unit. That means we want to get rid of the K for kilo. Well, kilo is 10 cubed. So we replace the kilo with times 10 to the third power, and then just simply write down the base unit, and boom, you're done. It's converted. Now, is it in proper scientific notation? No, but that's neither here nor there at the moment. It is converted. Simply replacing the prefix letter with the appropriate power of 10 converts it from here back to here, the base. All right? Now, then if it's not in proper scientific notation, you have 2 choices. If it's the answer for the problem that you're doing, yes, put it in scientific, proper scientific notation form. Just left, add, right, subtract. If it's not the answer, if it's what you need in the calculation to get the answer, don't worry about it. Leave it like it is. Let the calculator deal with the decimal. You just stick it in just like this. 12.6 E10 cubed. Just stick it in like that, and it will take care of it for you. You won't have to worry about it. So let's look down here at taking these metric prefixes and converting back to the base unit. All right? So if we have 123 millimeters and we want to go back to the base unit of the meter, that means we want to get rid of the milli. So first we write down the 123, okay? And then we're going to say times 10, because we're going to replace the milli with 10 to the negative 3. So 10 to the negative 3, and then write down the base unit. And there you go. 123 times 10 to the negative 3 meters. It is converted. All right? There's nothing else you have to do to convert it. Now, is it in proper scientific notation form? No, because the decimal is right here instead of behind the 1. So since it does say put the answer in proper form, we can now do that. So we're going to first move the decimal 2 places left, 1.23. And because we moved it 2 places to the left, we're going to add 2 to the negative 3, and negative 3 plus 2 is negative 1, and then write down the unit, the meter. So 1.23 times 10 to the negative 1 meters. All right, look at the next one. We're going to write down the measure, and we're going to say times 10. We want to go from kilometers to meters. Kilo is 10 cubed, positive 3. So we're going to put a positive 3 for the power, get rid of the K, leave the meter behind. Is it proper form? No. So we're going to move the decimal 1 place to the right. We're going to subtract 1, and we get 8.5 times 10 to the 2 meters. Okay? Look at the next one. 62 centigrams. Okay? 62 centigrams. So we're going to say 62 times 10. Centi is negative 2. All right? And we're going to write that down there, and then we don't have centi anymore. We just have grams. And it's converted. Not proper form, though. So we're going to say move the decimal 1 place to the left, add 1 to the power of 10, and the unit. All right. Take this moment to go down through there and see if you can do the others yourself. All right, I'm going to put the final answers that I have on here, but go ahead and try them yourself first and see if you can do them. Now remember, first convert, then worry about proper scientific notation form, okay? So all you have to do is take each metric prefix, replace it with times 10 to the power that it goes with, and it's converted. Just remember to drop the prefix, keep the base. Okay? Because you're going from the decimal place of the mega back to the ones place, the gram. All right, here's another one. Now, once you've converted, then worry about whether it's proper form. Okay? Convert first, then worry about proper form. All right, so those are the answers I have. If you have any questions about that, please feel free to message me, okay? Or if you're going to be in class physically, you can talk to me about it there. Also, try to do the handout that's there. I may make that assignment, it depends. But there is a handout, a practice handout that goes with this. So you'll want to get that. You don't have to print it out. You can always put the answers just on your own paper. But you might want to write down the given information first as well as the answer. So, okay, I hope that has helped you with that. We will later on worry about what to do if you want to go from one prefix to another prefix. For right now, let's just worry about making sure we can go from the prefix back to the base. All right, from one of these back to the base. Let's worry about that first. Thank you very much.